I'm CK. Tonight we're going to be doing another Gikfun kit. This one is an infrared backup camera or backup sensor. The package says that it's for Arduino, but I think it works standalone also. We'll see. We'll put it together and see. Hope you enjoy the video. Here's the bag. Gikfun SMD, I think. Infrared ... for Arduino. Again, but I think that that's inaccurate. I think it can be standalone too. And of course, I've had good success with Gikfun kits, and we'll remember their motto: give one kit, find one new life, making dreams, passing happiness. And I basically agree with that. Part of the reason why I do this channel is because I believe that a youngster introduced to building things, even if it's assembling simple kits, gets a lot of benefit from that, from self-confidence to exploration to learning very specific things. So I am all in favor of kits, as you probably can tell. But let's get in here and open the bag up. Static bag, and inside the static bag is another bag. Let's see, we got a piece of paper. Take a look at the piece of paper. SMD infrared reversing radar. It's a multi-resonant circuit, an infrared signal transmitting and receiving circuit, and a couple of others. And it uses a basic 555 IC, which is, they're ubiquitous. They're in everything. They're the counter, timer, oscillator chip that is everywhere. It has a schematic, so your beginning builder, or you, can trace through and see how it actually works. Tips to do it, and debugging. A nice component list with the locations on the circuit board. So we'll see what the circuit board looks like, see if it's got values marked on it or not. That'll be the next thing we pull out. On the back, it's pretty simple. A huge ground plane. But pretty simple. There can't be many components, except there are a bunch of surface mount components. So we'll be playing with those, and I'll talk about my technique for doing hand circuit surface mount. So these are all showing the component values. So you don't need this necessarily. The only thing you need, oh, hold on, first let's examine the board a little more completely. It looks, again, it's a Gikfun board, and I've been very surprised at how good their circuit boards are. Other inexpensive kit manufacturers out of China, I found, can use some low quality circuit boards. Gikfun doesn't. These are high quality. Through all the holes are through hole plated. The board itself is thin and dense. It's a good quality board. But in the end, we've got a bunch of surface mount to do, and most of them are resistors. There are 2 ICs, and that's where we'll spend most of our time. So I'm going to just rudely dump these out. So let's look at the easy ones first. There's a couple of trimmers, and the trimmer's legs are all bent. Seems to happen all the time. Power connector for a little power cord. A couple of diodes. 4 light emitting diodes. Actually not 4 light, yes. 4 light emitting, no, I keep saying that, but I'm wrong. This is the infrared diode, and this is the infrared pickup. So I don't know where these go. Parts list. The infrared emitting diode, which will be this guy, the clear one, is at D3, and the receiving diode is at D4. There's a handy way to check diodes, LEDs I mean, for functionality, and sometimes you can't tell what color they are because they're in a white plastic package, and the color is not discernible until you turn it on. Well, I'm going to show you how to do that. Get your meter, any brand, any type, and go to the continuity section. That's the section where when you touch your leads, it beeps to give you continuity, and when you put it on a piece of wire or something like that, it'll give you a beep to say yes, there's continuity between there. Now what that means, and I'm going to turn this light off for a minute, what that means is there is actual current. The batteries you have in the meter are actually putting current and voltage through the probes. So if you want to know if an LED works, and I'm going to splay these legs a little bit because I'm going fast, put the positive probe of your meter and the negative probe, and see that? It's lighting up. So that can do a couple of things for you. First, you can say if you got a grab bag of parts and you don't know whether all the LEDs work, you can check them really quickly. The other thing is you can obviously check the polarity, because if you do it backwards, say somebody clipped the legs and there's no flat spot, so you can't tell which side is which. If I put the negative side on the positive lead and the positive, it doesn't light up. Go the reverse, it does. So you can tell which lead is positive and which lead is negative without knowing anything. So I wanted to put it on this infrared LED, that's why I went through all this rigmarole. I want to put it on this infrared LED and see if I see anything. You know, it's interesting, it'll probably show up on the CCD screen on the camera more than it will in my visual perception. So you may be seeing something that I'm not seeing. So I'm not seeing anything from that. So that's how you can quickly check LEDs with your meter and not have any special tools or a test jig or start up a power supply or something like that. So that can be very handy. A couple of four electrolytic capacitors. Then a couple of disc caps. The two surface mount ICs, these little guys here. Then these contain all our resistors, and the resistors are all marked. These are all 102s. These are 201s, 103s, and so on. Again, the numbering convention communicates to you what the resistance of the package is, and you can look up to see how best to determine that. We'll put the surface mount components on, and we're going to start with the hardest ones, which are going to be the two ICs. Now, as you can see, I've zoomed in a good bit on the circuit board so you can see what I'm going to be doing. And to describe a couple of things. First thing, we're going to need some good tweezers. Two kinds, the flat nose kind and these pointy nose kinds. I did a video on tweezers. I'll link it in the description, or you can search for it on my page, one or the other. The other thing you're going to need is some solder flux. This is rosin paste flux. Be sure you don't get acid core flux. Don't get acid flux. That's for plumbing. Get rosin paste flux. What we're going to use it for is, as you can see, these solder pads are very close together, and the pins on the chip are very close together. Oh, the one other thing we're going to need. This is the thinnest solder I have. It is 0.025 inch diameter. I don't know how many fractions of a millimeter that is because I'm not a communist. But you want the thinnest solder you can get. And amazingly, this stuff, which comes from MG Chemicals, this actually has flux inside. It has a flux channel inside. I don't know. They're really good at their jobs to be able to do that. Now the first thing I'm going to do, and I apologize, I may get my head in the shot at various times during this, but surface mount really, you gotta get your face in there so you can see it. So the first thing I'm going to do is I'm going to take a little bit of solder and I'm going to put it on one solder pad. So as you may be able to see there, I've got a little bit of solder on that pad. Now I'm going to be taking, we're not using any flux yet, as you can see. Now we're going to take this chip, and this is where I'm going to get my head in the shot, and we're going to align the pins over the pads, and I'm going to heat that one little area up again. That one little, and you can see, you may have seen it. It moved a little bit, sunk in, and now it's not going anywhere. And I can double check that all the pins are over their appropriate solder pads on the board. Now you say, well, golly gosh, how am I going to get in there and solder it so I only touch one pin? Well, you don't. That's where your friend solder paste flux comes in. You get a little gloop of this stuff and you rub it along the pins, and what this does is it will be creating a barrier of liquid flux between the pins and the metal pads on the, and I just pulled it off a little bit so I'm readjusting, between the pins and the pads on the board, and solder won't flow between it. So the solder will naturally try and find its path, which is metal to metal. That's the way it adheres best. It doesn't adhere to the plastic here, I mean the composite of the circuit board, and the flux makes it so it won't jump between pins because it's attracted, and I'm misusing those words, but this is just conceptually the way I think about it. So what we're going to do, now that we've got our flux spread all along there, is we're just going to kind of melt solder all along there and gloop it all on. And there's a little bit too much went on there, but that's okay because we'll suck that back out. Oops. And I screwed up. I moved it. This moved on me. I'm surprised. Now I gotta realign that. There we go. But as you can see, or maybe you can't, because it is very hard to tell, all the pins are now connected to their appropriate pads on the circuit board, and nothing bridged except for that one place where it did, and I just sucked the extra off, and it sucked it off the green composite material, not off the pin area. So I'm going to do that again here. I'm going to be a little more gentle here and do almost like regular soldering. But you can see how it jumps from the pin to the pad. Come on, do like I said, jump from the pin to the pad. So those are all good. And of course I did the other thing. I really get annoyed with myself. As I was flopping solder around, I filled in this hole for the diodes that we'll put in later. but I'll go ahead and suck that free right now. So that's the way you do it. That's the way I do it. I'll show you, it's a little different for the resistors, and I'm double checking these pins because that one did slide on me, and I want to make sure that I've got conductivity. Now it's all good, and we can move on to the big IC. So I'm going to do the... I'll talk about... never mind. I'll talk about something when we do the resistors. So I'm going to do the same thing here. So that one's all soldered down too. Now we'll do the resistors. They're a little easier and slightly different technique. Let's see, which ones should we do first? I think we'll do all the 102s first. And there's our 102s. I'm going to get a separate parts bin to put these in. And I know I'm still zoomed in very tightly, but I want you to have a chance to see what I'm doing. First, we dump them all into the bin. And now, somewhat similar, I'm gonna put a solder glob on there. I'm going to do it for both of these because they're both 102s. And now I'll use my fine point angled tweezers to pick up a resistor. And similar to the IC, I'm going to heat up the solder pad, and the resistor sinks down into it. We've got good conductivity. Then I will use my solder to tack the other side down like that. Now, you might say to yourself, because I did, well, why don't I just put solder balls on both ends and just zap zap sink it down? I tried that. You may be more successful at it than I, but I tried that, and since you can't comfortably heat both solder points at the same time, you may be able to. I was not able to. It becomes uneven and a balancing act, and I was not successful with that. So I tend to just do one pad pre-soldered, and then I'll come back around and do the other legs. I'm going to do the other 102 solder pads. There we go. And there's a couple of there's a 102 over here. Oh, and I forgot to mention, or I forget if I mentioned that I did wash this board off with a little acetone when I got it to degrease it, just to make sure that the solder and other things would flow appropriately. Okay, I'm going to do one more resistor at normal speed, and then I'll accelerate the playback on the rest of these, because I don't think you need to see me do every single one of them. Now, as you can see, I haven't added extra flux to this. You can. It can sometimes make the solder joint flow faster or better, but I generally don't. So back into fast motion. The playback speed will speed up while I do all this, while I do the rest of these. And I want to mention two other things before I move on. First, these resistors are of course not polarized, so it doesn't matter which orientation you put them in, left or right, or even you could even flip them over if you wanted and have them upside down, then you couldn't see the value, but you may want to do that just for fun. The other thing to be aware of is as you get more and more stuff on the board, you don't want to have your soldering iron linger around surface mounted parts, because they can pick up enough heat to lose solder to get jounced a little bit to the side, and then again you'll run into sadness. So I'm going to do the rest of the resistors, but I'm going to do them off camera. And there's all the surface mount components on the board. Two things I want to finish up with. First, the really hard part, which is getting the resistors out of the little paper and plastic carrier, I can't help you with. I spaz on that all the time. The other thing is, as you can see, this is the way I do it. I'm going to back the zoom off on the top camera because we're going back to regular type soldering work. Okay, now we're going to do the other componentry. Do the diodes next. Oops, wait a gosh darn minute. That 102 that I thought was extra is not an extra. I'm sorry, I missed a surface mount component here in the middle of the board. I'm glad I found that, or else I would have been very sad when it didn't work and I didn't know why. I always wonder how many people saw it when I didn't and were yelling at the screen, "You forgot one, you idiot," like I've done often enough. It does give me a chance to mention one more thing about surface mount stuff. One thing you want to do is you want to keep the tips of your tweezers, wipe them off periodically, because they will pick up flux even from regular solder, not even globbed on flux, and it'll make the jaws a little bit sticky. And because these surface mount components are so light, a little sticky means you'll pick up the resistor or transistor or voltage regulator or chip and move it when you didn't want to. So wipe your tip of your soldering iron, your tweezers down often. Where was I? I was talking about diodes. There are two diodes. They're both 4148s. I just realized I don't know how much power this takes. Oh, 9 volt. Huh, okay. We certainly have that. I'm going to go ahead and put all the components on all at once and solder them all at once. That's 47 nanofarad. Okay, we're going to put the trimmer pots on, and as you can see, the legs got a little snaggly, so we'll use our needle nose pliers to straighten them out and get them parallel with each other. And I think these are the same value. 50K and 500K, they are not the same value. So This is a 504 and this is a 503. So this is the 50K because it's 50. And then a 3, which means 3 zeros, so 50,000. This is a 50 with 4 zeros, so that's 500,000. So you want to make sure you get them right, obviously. And the little adjustment screw goes over the little adjustment screw symbol on this circuit board. Now we'll put all the LEDs in. And again, long lead is positive, short lead and flat spot on the LED is negative. Now I'm going to look at the parts list one more time to verify that the emitting diode is D3 and the receiver is D4. So put the emitter in D3. And the receiver in D4. One final thing to solder. The power connector, and as you can see it's got a little cutout here which matches the open portion on the plastic connector. And that is all the soldering. That's the way she looks from the top, from the side, other side, bottom, other side. Now I'm going to scare up a 9-volt connector to connect this to, and I'll be back in a little bit. Well, I couldn't find the 9-volt battery connector I was looking for, so instead of spending a bunch of time looking for that, I'll just use one of my little DC power supplies, benchtop power supplies that come from a kit. You can see a build video of this on my channel. When all else fails, use brute force. So I just grabbed some more wire and I soldered it directly to the terminals on the board. So now this should have the power it needs to turn on. There we go. Now we've got 3 LEDs lit. I don't know what the heck that means, but we've got 3 LEDs lit. In case of no obstruction among the transmitting and receiving tube, adjust RP1 causes LED 3 on the circuit board to illuminate, then adjust RP1 in the opposite direction so LED 3 just goes out. Okay, so we're going to use RP1. I wonder what RP2 is for. But we're going to use RP1 to adjust the sensitivity of all this. So we want to turn it, I don't know which way we're going. Okay, the red is out. I think we want to have yellow out too. I don't know if I can get that. But red is out. Now we're going to take a reflective surface, this little piece of paper, and we'll move it close and close and close, and there, at about, you can see that, right? At about 4 inches, the red LED comes on. I'll do it for the side camera too. So that's pretty neat. And I'm sure we can adjust the distance. I'm going to start turning RP2 and see if that does anything. I don't think it does, or nothing. I'm sure it does something. Probably, I think these are changing the frequency of the oscillations in the 555 chip. Oh, look at that. Okay, so that is making it a little bit further away that it triggers off. Maybe I'm wrong. No, I don't know what this one does. I'm going to try backing this one off a little bit more to get rid of the yellow. There. Now we've got the yellow gone, and the yellow will come in first, and then the red. Very nice. So obviously you can adjust all the other parameters. You can play with the sensitivities on these two resistive trimmers, and if you do a little independent research into the 555 timer chip, you'll probably get a better understanding of what these two resistive values are doing. I'm not going to go into it because there are much better explanations of how a 555 works on YouTube or other places, and I would not be doing it justice. I recommend you take a look at it. But this is very neat. It's a good kit. Look, see? Little bit close, yellow light, closer, red light. And with the full schematic, so you can have your young builder understand what everything is doing. Some surface mount, but not too much and not too difficult. These can be a bit of a challenge, but keep working on it and use a lot of flux and have your solder sucker ready just to get rid of your mistakes. It's pretty forgiving if you are persistent and don't panic when something goes wrong. Solder sucker and a little heat fixes everything. So that's another very nice kit from Gikfun, and I hope you enjoyed the video.